In this video, we're going to be solving quadratic word problems, and we're specifically going to be looking at how we write the equation for a vertical motion word problem.
So the first type of word problem we're going to look at is we're going to take a look at these vertical motion word problems. So make sure you have this generic equation written down in your notes. So that's h, or our height, equals negative 16t squared plus v sub 0t plus h sub 0t. And then remember what these four variables mean. So remember that our h value is equal to the height. So this is the height of an object, and it is the vertical height. So it's how far it's going up. Then the t value represents time, which for vertical motion problems will be represented by seconds.
Then v sub 0 is the initial vertical velocity. And essentially what this means is it represents the velocity or the speed going upwards or downwards of that particular object at the start. So notice that this can be upwards or downwards. If it's upwards because it's going up, that v sub 0 value is going to be a positive value. However, in the chance that its velocity is actually going downwards, because velocity has a direction, the velocity, if it was going downwards to start, would actually be negative. So pay close attention to upwards velocity versus downwards velocity. Then from here, our h sub 0 is the initial vertical height. So this might be something that you use if maybe an object doesn't start on the ground, but it starts somewhere above the ground, maybe on a platform, maybe it's a ball being kicked, and so it gets kicked, 3 feet above the ground, whatever that might be. H sub 0 is that initial vertical height. So a couple of things to note here is that anything that has an h in it is representing height. Anything that has a v in it is representing that velocity. Anything with a t is representing the time in seconds, and then anything with this little 0 here, what this is really representing is it's saying this is the velocity or this is the height at time equals 0, and that's why it's called initial velocity and initial height, because it's what's happening at the very start, at the initial start of the problem.
So now let's read through this word problem together. It says a juggler tosses a ball into the air. The ball leaves the juggler's hands 4 feet above the ground and has an initial velocity of 30 feet per second. Write an equation to represent this situation. So we're going to start with that part first because that's our first instruction. So we're going to write an equation here to represent this situation. Well, we know that vertical motion is represented by this equation in general. So we have h equals negative 16t squared plus the initial velocity times t plus the initial height. So let's find that key information there. What I notice right off the bat is that our initial velocity is equal to 30. Our initial height is when it's released, so that's equal to 4. And as a result, we're able to substitute into this equation all the values we need. So we have h is equal to negative 16t squared plus 30t plus 4. So here is the equation that we need in order to solve the rest of this situation. So now that we have an equation, let's look at part 2. And this says, then determine how long the ball is in the air if the juggler catches the ball when it falls back to a height of 3 feet. So what we're trying to find is we want to find the time when h is equal to 3. So what we're going to do is we're going to take this value of 3 and we're going to substitute it in here for h. So if we rewrite this, we have 3 equals negative 16t squared plus 30t plus 4. And this is the quadratic equation that I need to solve. So if I take a look at this equation here, what I notice is that it's almost perfectly set up for the quadratic formula. All I need to do here is subtract 3 from each side, And if I do so, it's then set equal to 0. So I have 0 equals negative 16t squared plus 30t plus 1. So this is now set up for the quadratic formula. So I find my values for a, which is negative 16, b, which is 30, and c, which is 1. And then I can substitute these into the quadratic formula. So here I take x equals negative b, which is 30, plus or minus the square root of b squared, so 30 squared, then minus 4 times negative 16 times c, which is 1, all over 2 times negative 16. Now, I'm going to use keep change here because that's just easier for me so I don't make an error. Now that I've substituted, I'm going to simplify that part underneath the square root. So I have x equals negative 30 plus or minus the square root of 964 all over negative 32. Now with the problems we've done so far, we've simplified the square roots, but because this is a word problem, we want to make a little bit more sense of this particular situation, so we're actually going to estimate that square root. We're going to take the square root of 964 and we're going to estimate it out. So we have x equals negative 30 plus or minus 31.05 all divided by negative 32. So we're going to write that out there, and then we're going to just estimate what the time would be. So again, typically we simplify that square root and we leave it as a simplified square root, but since this is a word problem, we're actually going to estimate it out with some decimals. So now let's split this out. So we have negative 30 plus 31.05 divided by negative 32. And that becomes 1.05 over negative 32, which if I divide that out gives me a time of negative 0.03 seconds, which really doesn't make much sense. Let's see what that second option becomes. So we have a negative 30 minus 31.05 all divided by negative 32. And that becomes a negative 61.05 over a negative 32. And if I divide that out, I find that I get a time of approximately 1.91 seconds. And that to me makes a little bit more sense. So here's our answer down here of 1.91 seconds, which means if we release it at 4 feet and we catch that ball at 3 feet with an initial velocity of 30 feet per second, we will catch the ball about 1.91 seconds later.